What is grooving, everyone? It's a great day for math, and I'm excited to get into it with you. So last video, we introduced how to expand our horizons with fractions and look at fractions everywhere on the number line. Not just between 0 and 1 anymore, but negative fractions as well as fractions bigger than 1, which we introduced using both mixed numbers and improper fractions. So we're going to get some practice with these concepts today. So pause the video, give these a shot, and then we will go through them together. Alrighty, so question 1 says calculate the following and express your answer as improper fractions when applicable. Alright, so we just have some addition and subtraction problems here. Some of them are involving improper fractions, but that's alright because, well, we saw in the last video that they pretty much work the exact same. They just express numbers that are bigger than 1. So let's look at A, which is 11 halves minus 4 fifths. So we need to create a common denominator. So to do that, we need to figure out, okay, what's the lowest common multiple of 2 and 5? But 2 and 5 are both prime numbers, so that means the lowest common multiple is just going to be their product, which will be 10. So to get 10 in the first one, we need to multiply the numerator and denominator both by 5, and to get 10 in the second one, we need to multiply the numerator and denominator both by 2. Doing that, we'll get 11 times 5, which is 55 over 10. And 4 times 2, which is 8 over 10. So subtracting 8 from 55, we arrive at 47 over 10. And that's an improper fraction. That's as simplified as it gets, since 10 and 47 are co-prime with each other. So this will be our final answer. Let's move on to part B. So this has 3 pieces in it, so we're looking at 3/9 minus 20/3, there's an improper fraction there, plus 1/6. Alright, so we want to figure out what's the lowest common multiple of 3, 6, and 9. So 3 is just 3, right? That's already a prime number. 6, though, that can be expressed as 2 times 3, and 9 can be expressed as 3 times 3. So to get a lowest common multiple, which will be a multiple of all of these numbers, we just need to make sure all of these prime factorizations are covered. So that's going to be covered by 2 times 3 times 3. Since the 3 here is covered, the 2 times 3 is covered, and the 3 times 3 is covered. So this is the smallest covering we can make of these prime factors. And that's going to give us 18 for our lowest common multiple. Alright, so for the first one, to get 9 to 18, we need to multiply the numerator and denominator by 2 each. And then for the second one, we need to multiply the numerator and denominator by 6 each. And for the last one here, we need to multiply the numerator and denominator by 3 each. And doing that is going to give us 6 over 18 minus 6 times 20 is 120 over 18. And then plus 3 over 18. So combining these, we're looking at 6 minus 120 plus 3 over 18. If we do 6 plus 3, that's going to be 9. So we're looking at 9 minus 120 over 18. And 9 minus 120 is negative 111 over 18. Now this can actually be simplified, since you might notice both 111 and 18 are divisible by 3. Right? If we add up their digits, 1 plus 1 plus 1, we get 3, so it has to be a multiple of 3, and same with 18. 1 plus 8 is 9, multiple of 3. So if we divide both of these by 3, what do we get? You'll end up getting 37 over 6. Since 37 times 3 is 111, and 6 times 3 is 18. So this will be the simplified answer. Let's look at part C now. 120 plus 3/7. So this one's a little bit interesting because we don't actually have a fraction here, right? So how are we going to even make a common denominator? Well, 120, that can be written as 120 over 1. Because, well, this is saying 120 divided by 1, and that's just 120, right? So we can actually write any whole number as a fraction, and that will allow us to now proceed to make a common denominator. The common denominator in this case is just going to be 7, because 1 times 7 is 7, so that'll be common between them. So let's multiply the numerator and denominator by 7 each. So if you want to do 120 times 7 on the side, we can. So 7 times 0 is 0, 7 times 2 is 14, bring the carry of a 1 up there, and 7 times 1 is 7, plus that carry gives us 840. So we're going to get 840 over 7, and then we're adding it to 3 over 7. So in total this becomes 843 over 7, and you can check, but that's going to be simplified. And if you'd like some extra practice with that, just choose your own fractions. Could be normal ones like 4/5 or improper ones like 11/2, or choose some whole numbers as well like 120, and then just practice adding and subtracting them with each other. You're going to get various common denominators, and you're going to see various scenarios, and you're going to get good amount of practice with this. Question 2 says, express the following blue proportions as mixed numbers and improper fractions. Okay, so we need to basically do two things for each of these parts. Express it as a mixed number and an improper fraction. So for the first part, we see that 2 of the full rectangles are shaded in. So that means 2 is going to be the whole number part of our mixed number. And then for this last one, there's 2 pieces and 1 of them are shaded in, so that is a half. So 2.5 will be the mixed number that expresses this amount here. For an improper fraction, we need to basically express it as something out of 2, since we see here that our pieces are out of 2 there. And even though these ones don't look like they're out of 2, we can draw some lines in here, and then it becomes a little more clear that, yeah, these are actually out of 2 pieces, right? So this is 1, 2, 3, 4, 5 pieces that are of size 1/2. So our improper fraction to represent this would be 5 over 2. All right, so let's go on to part B now. So part B, let's start with the mixed number one again. So the mixed number one, we see, okay, this is completely full. This one is split into quarters, but it is also still full, right? So we can think of this as 2. And then over here, we have 1/3, and over here we have 1/2. So in order to consider the fraction represented by both of these, we're going to have to add 1/3 to 1/2. So if we do 1/3 plus 1/2, well, we need to make a common denominator, which is going to be 6. 1/3 expressed as a fraction with that common denominator would become 2 out of 6, right? These are equivalent to each other. And then 1/2, we're going to have to multiply the numerator and denominator by 3 each to get to the common denominator. So this becomes 3 over 6. So in total, we get 5 over 6 is what's represented by these two pieces here. So if that represents 5 out of 6, then we just add that on as the fractional part of our mixed number, and we get that the total blue amount here is 2 5/6. So to express this as an improper fraction, can we do this trick up here where we split them into kind of all the same size piece? Well, this one we can split up however we want. This one, it looks like it's already split up, but we'll do something about that in a second. And these ones, well, we already know that these contribute an area of 5/6. And we can think about that by splitting these ones up into 2 and these ones up into 3 each. And we see now that this is the 2 6s that was right here, and this is the 3 6s that was right here. Right, we saw this when we first learned how to find equivalent fractions and simplified fractions. This was one way to express it. So these are now split up into 6s. So then I could split this one up into 6s as well. Right? But now our problem is this one. It's split up into 4s, and we can't really split that into 6s easy. However, this is completely full, right? So we can just kind of ignore these lines, and we can just imagine it. We can reimagine this full rectangle as being completely full and being split up into 6 pieces, right? It's the same area, so we're just kind of redistributing them. And doing that now, we see, okay, we get 6, 12, 13, 14, 15, 16, 17 pieces that are of size 1/6. So the improper fraction would then be 17 over 6. So all we had to do was basically just kind of figure out how we could split all these up into the same size of pieces. This one required us to just kind of redistribute where the lines were, but that wasn't much of an issue because we knew the whole thing was filled in anyway, so we could kind of segment it however we want. Alright, so that was question 2. Let's move on to question 3. Alright, so this says convert the following into decimals. So For improper fractions, we saw the way to convert them to decimals was the exact same as what we saw with converting regular fractions to decimals. We just have to do some long division. So 93 divided by 2. How many times does 2 go into 9? It goes in 4 times, right? Since 4 times 2 is 8, which we'll then subtract off, get a remainder of 1. Then we bring down our 3. How many times does 2 go into 3? Well, 12 is going to be the closest even number below 13, so 2 will go in 6 times. Subtract off 12, we get 1. And now we have to add our decimal 0. Bring that down. 2 goes into 10 5 times, and let's not forget the decimal there. Subtract off 10, we get 0, so now we're done. So 93 over 2 is just 46.5. So we converted it into a decimal. Let's move to part B. So to convert a mixed number into a fraction, we saw that we basically had to think about what the mixed number is, where it's really just the whole number plus the fraction part. And then we had to convert the fraction part into a decimal, which is the exact same process over here. So we get 0.6 is the same as 3/5. So we have 2 plus 0.6 becomes 2.6. All right, let's move on to part C. So we have negative 300 over 9. So this is the same as negative 300 divided by 9. Negative divided by a positive is negative, so we can expect a negative decimal here. And what we do is we just do 300 divided by 9 like this. I'm going to add in the negative afterwards, but we don't really need that for this part here. So let's go ahead and do that. And we see we're getting the same thing over and over again, right? 30, 27, 30, 27, 30, 27. And it's going to keep on going. So our answer is then going to be 33.3 repeating. But once again, it's a negative number divided by a positive. So we are going to get a negative answer. So this will be negative 33.3 repeating. All right, so not too bad. And let's do the last part of this question. We have negative 180 and 3/8. So we saw up here that, okay, a mixed number is just the whole number plus the fraction part. But in the case of subtraction, because the whole thing is negative, we need to think of it as a negative 180 minus 3/8, right? Or we can think of it as plus negative 3/8. So now we just need to convert this 3/8 into a fraction. And we get 0.375. So this then becomes negative 180 minus 0.375. Since these are both going in the negative direction, we can basically just add their magnitudes. So this becomes negative 180.375. All right, so that's part 3. And for extra practice, just kind of do what I did. Make up various positive and negative mixed numbers and improper fractions, and practice converting them into decimals. And again, you can check your work by just using that fraction to decimal buttons on your calculator, or just look it up online if you don't have that available to you. And let's go on to part 4. All right, so this says convert the following into improper fractions and mixed numbers. So it's just the opposite of the problem we just did. Instead of going from these to decimals, we're going backwards. And we have to do 2 things for this. We have to, for each one of these, convert it into an improper fraction and then convert it into a mixed number. All right, so we'll start with 1.12, and we'll just go in order here. So we'll start with improper fractions. So the method we used to convert decimals into improper fractions was the same method we used to convert decimals into regular fractions. So what we do is we just rewrite the number without any decimal, and we see how many times the decimal was slid over. 1, 2 times, right? So that means we have to divide by a power of 10, which has 2 zeros, so that's going to be 100. So we get 112 over 100, and we can simplify this, of course. They're both divisible by 4. So 112 divided by 4, that is going to be 28. And 100 divided by 4 is going to be 25. And those are co-prime with each other, so that is going to be our simplified answer. And now we also want to write this as a mixed number. So the way we did that was we want to basically split up the whole number in the decimal part, because again, a mixed number is basically a whole number and a fraction part, so it makes sense that we want to split it up this way. So this is going to be 1 plus 0.12, and then we need to convert the 0.12 into a fraction. So this is going to be 1 plus 12 over 100, and we can simplify 12 over 100 to being, these are both divisible by 4, so this simplifies to 3 over 25. So we get 1 and 3/25, as our mixed number that represents this decimal. Let's do part B now. We're looking at negative 3.5. All right, so with the improper fractions method, we're just going to rewrite the number on top, negative 35 without the decimal. And it was only moved over one place by the looks of it, so this is going to be a denominator of 10. To simplify this, they're both divisible by 5, so we get negative 7 over 2 will be our simplified fraction. So that's our improper fraction that represents this decimal. But we can also do this with mixed numbers. So same method, we want to express this as basically chunking off the whole number part from the decimal part. So it's going to be negative 3, but it's not going to be plus 0.5, it's going to be minus 0.5, or we could think of it as plus negative 0.5. It's kind of up to you. We know from previous videos that these are the same thing. But now we need to convert this 0.5 into a fraction, right? Well, if you've done a lot of these, you'll know by now that 0.5 is just going to be a half, but we can do the long method. So this is 5 over 10, right? Because we moved the decimal over by 1. So this is going to be negative 3 minus 1/2. So that means that the mixed number is going to be negative 3.5. All right, let's move on to the last part. We've got 8.08. All right, so to convert this into an improper fraction, this is the same as 808, and we've moved the decimal over two places, so we have 100 in our denominator. Now we can simplify these. 808 and 100 are both divisible by 4. So if we divide the numerator and denominator by 4, we get 202 over 25, and these are going to be co-prime with each other because 25's factors are just 5 and 5, and 202 is not divisible by 5, so this is as simplified as it gets. All right, now let's put this into a mixed number. So 8.08, this is the same thing as 8 plus 0.08. So now we just need to convert 0.08 into a fraction. So this is 8 plus, and then 8 is in our numerator, but this time our decimal has been moved 2 places over, so we're going to have to divide by 100. 8 and 100 are both divisible by 4, so this becomes 8 plus 2 over 25, or 8 and 2 25ths. Alright, so that's your practice with converting decimals into improper fractions and mixed numbers. For extra practice, you can make up various decimals, like I did here, and practice converting them both into improper fractions and mixed numbers. Make sure to do both positives and negatives for some practice. But yeah, good work, and let's go on to part 5. Alright, so part 5 says, consider the decimals following the pattern 1.1, 1.01, 1.001, 1.0001. So these are like all the decimals that just kind of have a 1 with a decimal, and then however many zeros, and then a 1 at the end. So something like this would be a decimal that follows that pattern, right? Because we start with a 1, end with a 1, there's a decimal right after the first one, and then there's just a ton of zeros in between. So any decimal that looks like this are the ones that we're talking about for this problem. And it says justify why when any of these are converted into a simplified improper fraction, right? So they're going to be converted into fractions, and since they're all bigger than 1, it's going to be an improper fraction. They're always going to have a denominator that's a power of 10. All right, so for example, if we convert 1.1 into a simplified fraction, well, that's going to be 11. The decimal's been moved over by 1, so 11 over 10. And this can't be simplified further, and it's got a denominator that's a power of 10, right? This is 10 to the power of 1, all right? And let's try it for 1.01. So we have 1.01. We get 101, and the decimal's been moved over twice, so it's divided by 100. Okay, and you'll see that this can't be simplified either. So this also looks like it's following this property where the denominator has a power of 10 when it's simplified. So that what it's saying is, this is always going to be the case for decimals that look like this. So how can we justify why that's the case? Why is 11 tenths not simplifiable? Well, because 11 and 10 are co-prime, right? 101 and 100 are co-prime. We could even do 1.001. That's going to be 1001 over 1000. 1001 and 1000 are co-prime. How do I know this? They're consecutive numbers to each other, right? We've used this property for several questions throughout the series by now. If two numbers are consecutive, they are co-prime with each other. The thing is, the way these decimals are designed, when we convert them into fractions, we are going to be getting where the numerator is always 1 bigger than the denominator, right? Even this one right here. We have how many zeros? 1, 2, 3, 4, 5, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7, and then a 1. The decimal was moved over 1, 2, 3, 4, 5, 6, 7, 8 times. So we're dividing by basically 10 to the power of 8, or 1 with 8 zeros after it. And this numerator is just 1 bigger than the denominator. So it's already simplified because they're co-prime with each other, and it's got a denominator of a power of 10. So to write out what we're saying here, alright, so all of these numbers, when converted into fractions, will have a numerator that's 1 greater than the power of 10 than in the denominator, right? 11 is 1 greater than 10, 101 is 1 greater than 100, 1001 is 1 greater than 1000. So that means these numbers are consecutive, and thus they're co-prime, and thus the fraction is simplified, right? Numerator and denominator are co-prime, it's simplified. So we have a simplified fraction whose denominator will have a power of 10, which is what we were looking for. So we just showed that any decimal of this form has this property. Alright, well, good work today. I hope you found this video useful, and I hope that you're feeling a little more comfortable with this concept now. I'm looking forward to the next one, and I'm sure you are too. And you're getting better at math video by video, day by day, so keep up the good work. You have a good one, stay groovy, and I'll see you in that next video.
F.O.A. Maths.